Thanks for coming. We're gonna spend a few minutes talking. I would say this is a sort of more laid-back presentation, maybe not my traditional style. It sort of strikes somewhere in between half philosophical, half practical, or oh my god, I can't believe that code does that thing. So it does have some code. I do sort of want to use this opportunity to strike a conversation with some of you. So after we have this sort of interaction in a more structured manner, feel free to interrupt, ask me questions, or save them for the end, or even better, sort of corner me on the hallway after that, and let's discuss some more. I'm pretty sure you have some opinions about some of this stuff. So why should we be concerned with symmetry? So symmetry has been fascinating to the human mind, and sort of everyone who likes objects and patterns that are in some way symmetrical. Can be geometric symmetry or otherwise. So, and it's interesting fact that nature often exhibits these kinds of symmetries in objects, but also in phenomena, like I'm going to show. So we have a tendency in our mind to associate symmetry with something that we need to aspire for, or associate symmetry with some kind of regularity and perfection. And I'm going to try to explore that even in the context of code, right? But so often, we're almost nearly there, sort of, it almost eludes us sometimes. And I think it's just like a super old human frustration or obsession, I would say. It goes back to ancient Greeks who were sort of unwilling to accept that planetary orbits were not perfect circles. It's almost nearly perfect. So it is almost there, but not there. So we have a tendency to sort of push back on some of these things that we find strange, and sometimes we even go and swing to the other side and find beauty in asymmetrical things or surprising symmetries or asymmetries. So they come in all sorts of shapes, and even nature has a tendency to prefer some of these weirdnesses. So if we talk about chirality, if we talk about various properties of substances, of chemical reactions, or physical phenomena like polarization. Yeah, go in. Yeah. So they come in all sorts of shapes and forms, and they surprise us and intrigue us in various ways, and we sort of poke at them and see, is there more there, right? And I know who saw or is passionate about these kinds of things. I trained as a physicist, so for me this is sort of like going home. So I saw a bunch of hands, which is sort of, you're my audience. So, but for the others, this is not a super technical physics presentation series, but a super enjoyable one. I think it's accessible for everyone, sort of high school level, I would say, physics, from the sort of a great educator. So I sort of try to be cheeky about this and try to see if the way sort of follow in Feynman's footsteps there and sort of try and go on a quest for character of code. And I try to go through a bunch of these and try to identify some of these things, and then you end up with a lot of random ideas and a big list of things, and and they don't really form a coherent story. So I try to pick some things, because we can't just rant forever. I could talk for hours on some of these things. Anyway, from those symmetries, I'm going to highlight some of these things: translation in space, time, rotation, uniformity of velocity, Lorentz transformations, reversal of time, reflection in space, matter, antimatter kind of thing. So all super cool, interesting topics. So if you want to sort of deep dive, part 4 specifically focuses on symmetries. So what I want to sort of see how this connects to my obsession at looking at these kinds of things in code. So, and the reason is, it's not just about simple geometrical things and patterns and stuff, although we're going to see some, but it's observing properties of objects, and more specifically, the transformations that we can do on objects. And I think this was the first sort of milestone in this kind of pursuit, at least in mathematics. Who knows who this guy is? Anyone? Excellent. Excellent. Évariste Galois. A young, brilliant mathematician, died way too young. He tried to go into a duel and failed. He should stick to math. So he was the first one to have the insight that we can think about symmetries beyond geometry things, beyond obvious things that were explored up until that point. So think in terms of sets and polynomials and groups and all sorts of these abstract things and transformations that we can do with them. And if we go even beyond that, pop quiz again. Who knows who that guy is? One more. Shout it. Yes, Murray Gell-Mann. Yeah, from the quark fame, right? Nobel Prize physicist and for work on elementary particles. One of the greatest minds of the 20th century. So he said that elegant equations are probably more right than inelegant ones, right? And sort of in this lovely presentation, he explored sort of peeling the onions of mathematical encodings of physical phenomena in trying to find a more beautiful formulation for the same thing and trying to see if exploiting some of these symmetries in simplifying mathematical formulations yields new things, new discoveries. So sort of going from encoding known phenomena, trying to distill and formulate them in simpler ways and try to identify more symmetries, can we go and get insights into things that we don't know yet, right? So sort of a full circle from observation, experiment, formulation, mathematical analysis, and then yielding new hypotheses based on the formulations and the beauty and symmetries in those formulations. So one classical example is starting from Maxwell's equations, which are symmetrical under rotations of space. And the more symmetry you apply, the more, don't worry, this is not the topic of presentation. You're not supposed to read all those magical hieroglyphs. So, but the idea is that the more symmetries or different kinds of symmetries that we try to apply to these formulations, we simplify the formulation and we get a new level, a new, as he calls it, layers of the onion, sort of new level of understanding and new insights and hypotheses in how we analyze things. And I'm trying to do the same, but for what we do, right? So that's what I'm saying. It's like I'm trying to go on this sort of quest for character of code, sort of in a language-independent manner, but when I'm going to pick on C++ because that's why we're here. So trying to identify patterns, interested to see if these patterns exhibit some kind of symmetry that is advantageous in some way, either for readability or for performance, or I don't know, discoverability or refactoring opportunities. Who knows, right? So, yeah, these are some of the places where I've done some damage in the past or currently, and how you can get a hold of me and shout stuff at me on public. Right. So, I'm going to try to go through. Like I said, there's like I started a big document and I just keep adding stuff to it and all sorts of ideas that fall into this bucket, but they don't all sort of drive a point. And I sort of picked 3 that I feel like they work together and they're trying to drive a point. And like I said, I'm interested to maybe hear more from you, more such ideas. All right. So this talk, in case you were wondering, it's not about this kind of pursuit. Although I found it, I find, who has seen this presentation? It's not exactly new at this point. Just 4 hands, I see. Good. I highly recommend it. It's a very good presentation by Lisa Lippincott about sort of analysis, deep analysis of structure of programs, and sort of reason about sequencing, branching, loops, function termination, passing arguments, and so on. So it's a fantastic talk analyzing sort of shapes of programs and topology analysis on how to reason about programs and complexity. So, but I'm not going to talk about this now. So, and by the way, she did a great job, so I have very little to add there. Also, it's not about sort of program complexity. I'm not going to try to reason about some and quantify some of these things and come up with some synthetic things. There's papers, there's research, there's even commercial tools that do these kind of things. I'm not interested. I'm not saying they're not valuable, I'm not interested in them. I spoke earlier about some sort of these kinds of geometric symmetries or asymmetries. So when you look at code, you kind of tend to see things like this, sort of saw pattern-like things, especially in long functions that we love. And of course, the saw, because we have this sort of inherent need to do these kind of conditionals, and we like to indent stuff to be able to reason about them, right? Then there's your traditional, I'll dump everything in a function kind of thing, sort of the paragraphs way of organizing thoughts and computation. And then because some people come later and see, I don't get what this long function does, they will just like, oh, I'll explain it for the ones after me. And they'll add some handy comments instead of refactoring the function. By the way, if you see something like that, those are like independent functions, right? If they have a comment, that's probably the function name. Then there's patterns like unbalanced, so unbalanced if-else blocks. And you would say like, yeah, I'll stick whatever makes sense in each side of the predicate, right? It makes sense on the if or on the else side, right? So why should it matter that the if is more bloated than the else or the other way around? Like, why should it matter? It's just the right thing to do, right? Well, and when I look at these kinds of things, I ask questions like, why is the else doing just one thing and the if does a whole bunch of things, or the other way around? Like, I ask questions about why did we need to do that? I'm not saying it's wrong. It might do the right thing, but I'm asking questions. Did we organize the structure, the design of the computation we needed to do in a way that's good if we start doing all these kinds of imbalanced sort of blocks everywhere? Anyway, these are the kinds of obsessions I have. Just to break sort of from the patronizing and prescriptive to the sort of more light end of the spectrum. By the way, James is here around, not necessarily in the room, but around. So if you want to sort of corner him and start a conversation. So he did a while back, 2018, he did a lightning talk at CPPCon, which I found enormously hilarious. And I still find it from time to time, and I share it with people, and I watch the whole thing. It's just a couple of minutes. It's so good. Anyway, so he was sort of trying to poke fun of sort of the more methodical analysis like Lisa did, and clearly named the lightning talk as such. So he was analyzing program complexity by the sort of amount of indentation, sort of the how much mountain do you have there inside your function, inside your nested ifs and stuff. The more you have, the better, the worse it is, right? And you want to sort of improve the program by just minimizing that mountain you have in your function, that red thing. But although the talk was hilarious, it did have, I would say, deep truths there, and we need to think more serious about this. So, for example, a thing that we usually do is flatten things, right? Because we want to sort of see things in a more linear fashion. Sometimes we do it for performance reasons, sometimes we do it for readability or refactoring purposes. But we use these sort of guard patterns to do this thing. And we do basic things like early returns, or we use fancy RIII things, or we always use tricks to automate some of these things. But and some languages, like this one, even have invested a bit of syntax to help with this and improve. For example, again, you don't need to read Rust to get what's happening, and it's the most simplest thing I could put there. But imagine that you could have multiple indentation layers there, where you conditionally say if I'm matching this and if I'm matching that and if it's this, it's like the more nested you go. And the important thing that I care about, the happy thing, is right there nested, that okay thing, right? And everything else is sort of boilerplate error handling and the unhappy path, right? And sort of these kind of, we have this kind of let else syntactic sugar, where you help sort of flatten things out, get the errors out of the way, and have the sort of the meaningful, the meat of the, sorry for the vegetarians, the meat of the function right there where you can deal with it, and it occupies the right place in the function. It's not hidden somewhere deep inside that McNeilis mountain. So, and Swift has a similar thing. I think Swift was first. Same thing, you could have, again, it's a trivial thing, but I've seen much worse, trust me. And again, they have a similar pattern of using this guard let else kind of deal to handle the uninteresting part, and then focus on the important part of the function, right? So this is sort of a kind of, again, goes back to these kinds of shapes. How we organize code so that we can read it easily, we can refactor easily, and we can sort of reason about the whole thing, right? And I showed some of these examples in the context of functions, but you can see them in context of designs in a more bigger sense, in terms of how components hook together. You can see these kinds of things in how you handle dependencies and resilience with dependencies and all sorts of injection patterns. So it sort of proliferates in many ways. I just picked the sort of the easiest way to visualize these kinds of things. And then I know it's a sort of a weird teaser, but can anyone guess what these things have in common? And by the way, if you can't read the small things, it's sort of a branch prediction kind of thing. That schema, that diagram tries to allude to branch prediction and some kind of CPU things. Can you guess what they have in common? Yeah, but what does it have in common with the leaning Pisa tower? And I picked a point of view where it leans to the left, by the way. So code that is, generally code that is left-leaning tends to be faster, right? That, yeah, I overdid it. Anyway, so again, I'm going to point you to, you don't have to trust me, but if you want to see some really cool examples, and I'm going to highlight one from a long talk by Andrei Alexandrescu, where he explores sort of refining various, using various iterations and attempts to refine some algorithms, mostly around sorting. And the thing that I extracted as relevant here from that thing is the highlighted red box there. Right? Can anyone tell me now, in the context of the previous slide, why I highlighted that thing? Yeah, excellent, excellent. Just for everyone, it's sort of explanation is on this slide, don't worry. But so that was the exact thing. So the idea is that we want to encode logic for performance reasons, again, not for readability here. You always make trade-offs. But for performance reasons, in this case, it's more advantageous to encode logic, that the equivalent logic on the right-hand side, that if on the right-hand side, rather than have a concrete if and a branch encoded arithmetic. So exploiting properties of arithmetic to encode the logic within. I found, and these tricks are not exactly novel. We've seen them for years. If you look at programming pearls, there's a bunch of these cool things. But again, I find these kinds of things, sometimes people are looking and say, are you trying to be clever? No, we're trying to be fast, right? And there's trade-offs, of course. So the idea is that you want to position in the middle of the array, but differently in case you have odd and even number of elements. So you want to encode the conditional instead of an if through arithmetic, through computation. So another example where trying to exploit some kind of symmetry of asymmetry in computation leads to some emergent consequence. In this case, can be performance. Not always, right? So that's one example, and I highly recommend that you watch the whole thing. The present, not the the other thing, this thing. But this is fun too. So watch the whole presentation by Andre. It's full of interesting such observations. And he casually sort of drops them as in, oh, I just tried it like a dumb, he sort of always tries to be cheeky about it. I tried this dumb thing to see if it works and if it's better or what. Sort of almost like, oh, I'm like a child sort of randomly changing the code to see if I get better results. He actually knows what he's doing, but he's sort of trying to encourage us to think in this way, to look at the code and sort of be in this experimental mode all the time and try to see if we can spot some of these patterns and exploit some of these symmetries or asymmetries in how code executes, right? How we traverse things, how we search for things, how we index into arrays and so on. Okay, so moving to a different thing, would you consider this to be a symmetrical thing, just by looking at it, and me not telling you what it is? Does it look symmetrical in any way? Yeah, okay, people seem to agree. How about this one? Yeah. How about this one? I think you know where I'm going, right? Okay, so I'm going to spend some time talking about equality, because it's such a darn sweet subject to me. I did a bunch of rants on equality in the past, and we need to sort of build towards that, and they all tie in together in how we use concepts, either explicitly or implicitly, by the contract we have with standard library and the algorithms within. So whether we know it or not, or if we are in contract or not with these assumptions, we kind of have to deal with them, right? So we need to understand concepts like strict weak ordering if we care about sorting stuff in C++, right? And again, some of these symmetries and asymmetries come up in the properties of the functions we use as compare predicates, right? And how we define equivalence. Same formulation, but instead of math, you have the equivalent concept in C++ 20. Of course, properties of what it means to be equality comparable. And again, there's subtle nuances between equivalence and equality. If you want to go see the full rant, I have another presentation. It's called regular something. You can watch that, sort of go deep on these topics. But again, you can see some of these expectations. And you say, well, that's just like primary school math. Why are you wasting my time with these things? Well, you would be surprised. We're actually violating many of these assumptions when we're writing some custom types. Same thing, instead of math, using concepts. Don't need to reason about them. You can find them on CPP reference. So they all sort of build towards this regular concept that I spent many hours ranting about in the past. You can Google stuff about this. Just put my name in front of regular and you'll find stuff. Okay, and the same thing in concept form, just so that you see it's not about math, it's about C++. I'm not trying to deceive you here. Okay, so I would say, without going into the rabbit hole of doing another regular talk, I would say that defining equality is really hard. Seems like it should be a simple thing, but it's not. Even if you read the original Stepanov paper, he quotes that two objects are equal if their corresponding parts are equal, applied recursively, including remote parts, excluding inessential components, excluding components which identify related objects, and so on. And he concludes that it's like a long paragraph of trying to define these things in words, and he then says like, it still leaves room for judgment. I mean, he's not even convinced by what he's saying. And again, if we're going to our favorite aliens here that landed in 20, and talk about consistent comparison operations, and I'm not trying to say anything bad about spaceship. Spaceship is great. It brings a lot of convenience and consistency to what we do. And trust me, I've seen some inconsistent stuff in how people define these operators, manually, I mean. But you need to understand and reason about relationship strengths and what kinds of ordering guarantees you give for your types and how you use them, and sort of not break such assumptions. I think still one of the best explanations I know on these topics are some presentations that Jonathan Mueller did in the past, few years back. I don't have the links, I'm sorry. You can Google for them. So the idea is that the compiler will synthesize some of these things for you, but there's some asterisks involved, many of them. So for example, there's ways for you to intervene in the process and affect what compiler does based on what you define yourself. Same as with the special member functions, right? So many times you will need to define your own operator equal for efficiency, because the spaceship one will do the generic thing, and that will not be most efficient way to compare for equality in many situations. So think about implementing this optimally for some kind of wrapper type like the trivial one I present there, where you have some kind of vector of stuff. So if you look at it, traditional three-way compare will just blast through everything and sort of do nestingly do the three-way compare onto those elements, right? But this is not necessarily the most efficient thing, because, for example, you could, if you have unequal length things, you can short-circuit this thing really early and avoid doing any unnecessary comparisons. Whereas if you just rely on the synthesized one, that one can't make any assumption, it will just do the regular thing, right? And again, you say like, oh, it's just like real-life code is much simpler and more clear than all this nonsense. Like my code, I don't need that, right? I've lived without spaceship. I know how to write my operators. I never had time, right? So quiz time. Not that kind of quiz, but I do expect maybe some shouting and involvement. So names have been changed to protect the innocent, but I do know them. So no, I can't disclose that. Just some code, right? You have a string, just expect that all the functions you see here, although you don't see their bodies, they do what you expect them to do. There's no trick about what the implementation of the functions do, right? So I'm trying to build some string, and I'm trying to handle equality, inequality. I'm trying to get access to the buffer, and so I think we've all seen these kinds of things. I'm not saying they're great, but we do see them, and they are in code bases everywhere, in some form or another. And then the sort of the client code goes like this, right? And what would you expect to see there? Is it equal or not equal? The game is called equal or not equal. Okay, so the culprit here is this operator, right? So it calls the operator and leads to pointer comparison, which is not what we intended to do, right? So we intended to call the equality thing, right, which does the right thing. So what we end up is not equal. Okay, good. No surprises, right? But, then I'm going to say, okay, let me get rid of that thing, because maybe I don't even need it. I don't know. But clearly, almost everyone sort of identified and noted that, oh, that thing was the problem, right? So I'm going to comment the conversion operator, and then I'm going to be forced to flip things, right? So I'm going to be forced to flip them. So again, going back to what's left-hand side, what's right-hand side, right? If you go back to that table I showed where I defined equality, all those mathematical mumbo-jumbo symbols said that it needs to be the same thing. If I look at it like this or like this, right? Well, not exactly. So if I do comment the operator there, and I do the adjustment left-right, now they're equal, right? Yeah, fixed it, right? Sorry, the projector is really bad quality. I should have used some other kind of highlighting. So the equal is the one that's highlighted, right, over here. Okay, good. Then, going back, this is the initial form, right? The initial form that the author had in their source code, and it said not equal, right? Let me do some, so maybe I need this conversion, but maybe I say, well, you know what, it's stupid that it's, I actually only care about equality, right? The inequality thing, maybe I don't even need it, right? Why should I declare? Let me just experiment, right? Let me go full Andre mode, like just try every stupid thing until I make it work, right? So let me comment the not equal operator, right? And now it says it's equal. So now it works again, although I have the conversion to character array, right? So I have the conversion, but I commented the not equal thing, and now it works as I expected. And now I'm just freaking out, right? And I have no, like, compiler doesn't say anything. It says good, equal, no warning, no nothing, right? Again, going back to my original example, right? Not equal, the one that I'm trying to fix. Let me try a different thing. I'm a good boy, and I remember that I've been told that I should try to use explicit when I'm doing operators and constructors and stuff, right? Let me put an explicit in front of that thing. See if it makes a difference. I'm willing to try anything at this point, right? What do you think happens now? Same code, right? I made some room. Can you guess why the room is there? Yeah, it's for the error. Now, finally, I can use some tools to help me, right? So the compiler actually yells at me and says something that I'm trying to understand. Says, rewritten candidate function was excluded from overall resolution because of a corresponding not equal operator declared in the same scope. Aha! So that's why it worked when I commented the not equal operator. Now I understand why my random change made it work, possibly, right? And there's some mumbo-jumbo about compiler internals and why they suck at diagnostics. And so it tells me that there's some rule about how these things are rewritten. And by the way, this is in context of C++20, right? Tells me about there's some rule that nobody taught me about how functions are excluded and how these operators are synthesized. I can see some synthesized words there, and like it was rewritten, and I'm trying to understand these things, right? I'm a mere mortal. I don't know these kinds of things. So turns out that this is something that changed after this paper was implemented by compilers, P2468, revision 2. So it's cheekily named the equality operator you are looking for, not. And it starts, this is the very first intro sentence from the paper. This paper details some changes to make rewriting equality in expressions less of a breaking change. This is the way to sell C++. Less of a breaking change. And the gist of the thing that you should probably take away if you didn't already know it, is that in C++, the presence of operator not equal instructs the compiler to suppress operator rewriting, since the intention is to keep C++ style code compiling and working as expected, right? So in C++ mode, the code would have produced the exact same result. So the fix is trying to keep old code not breaking, but it has some interesting properties here. So the takeaway recommendation here would be to, as always, try to make things explicit as much as you can, and removing the not equal to make the code more C++20 friendly. So that would be sort of the the fix, right? And now it says it's equal, right? Ship it, I'm a genius. So who was surprised? I was. Who was surprised about this kind of shit? Problem. It's like maybe there's one hand that's not up, and they probably read the paper by Barry. Okay, good. So I feel less bad now. I feel like I've less of an imposter. Like, anyway, this is just one of the stories, and I want to sort of go here in my sort of more philosophical rant now. So we need to think more about sort of these kinds of incidental or deliberate symmetries. We need to think what operations do make sense for the things that I'm defining. Am I defining things for completeness? Am I trying to satisfy some kind of rule of n thing? Am I trying to add all possible functions that this type might need in the future? Am I trying to satisfy some mathematical axioms for the properties that are expected of the type I'm defining? I think we need to be less random about the stuff that we're putting in our types in terms of operations that we claim they support, and more deliberate of why we're doing it, right? And even documenting stuff about why we did that. For example, going back to that silly thing, why did the author choose to define equality? Well, that's the obvious. They needed it somewhere, right? But why did they choose to define inequality? And I didn't show the implementations. Do they actually do the opposite things? As in, does inequality actually does not equality operator, whatever equality operator does for my type, right? I've been surprised. I've seen situations where inequality doesn't do the opposite of equality. Right? I've seen that. You laugh, but I've seen it. And even going further than that, should I even define them? Or should I rely on the compiler doing it for me? When does it make sense for me to do what a compiler can already do for me? What kind of message am I sending to the user or the consumer of this type if I'm defining it myself? And even more so, if it almost seems like it's doing the default thing, right? Am I doing the default thing by accident? Was there something more there in the past and then it was deleted and now it just happens to be looking like equals default? Is that accidental? Is there a subtle difference that I'm missing, right? Was there a extra field in the past, or did anyone add an extra field that doesn't participate in equality? And is the code trying to model equivalence for this type instead of equality, right? For the purpose of some kind of predicate, right? So these are the kinds of things we need to think about. And I always find it very sort of concerning. These are the kinds of bullseyes I look in code, right? When I see these kinds of operators in a type, I'm immediately asking myself questions. Why were they defined, right? Or declared in some situations, or equal defaulted, right? Why was the author explicit about these things? So, and when we don't want something, an unexpected behavior or interpretation, should we be explicit about disallowing that operation, right? Put a stake in the ground and say, I'm not defining equality for this type, right? Think about span and laugh. So you know that span doesn't define equality, right? I have a 1 hour long rant about that. And a bunch of other more clever folks have nice articles online. Just Google span. Yeah. Anyway, so why should we care about these things? So we should try to generally look at these patterns in content, try to identify and see when does this thing make sense for different reasons. And there's different trade-offs, like I mentioned earlier. We can make trade-offs for resilience. We can make trade-offs for performance. We can make trade-offs for extensibility, maintenance, scaling things up, for readability, right? For composability of things, or the ability to do some kind of injection pattern, whatever. But we need to be explicit about some of these things when we do them. We can't have these sort of trapping users into recognizing a pattern in the types and the code that we're writing, and then breaking those assumptions by not exactly doing what they intuitively think that thing should be doing, right? So again, let's be deliberate. I would rather us withhold functionality and put a stake in the ground and say, I'm not supporting this operation for this type. I'm making an explicit choice of not supporting it. Or if I'm supporting it in a weird way, I'm going to give it a weird name, right? Rather than use equality and do some other thing that's not equality, right? Or inequality, or comparison, or some. So I'm not saying we don't need to do weird things. Yes, we do need to do weird things, but let's be very explicit. Let's not use something that is intuitively easy to identify and familiar, and make it not match the thing we're expecting, the thing that's natural to happen, and in equality, and or other, when we expect to see symmetrical operations that don't behave in a symmetrical fashion, right? These kinds of things, right? So anyway, this is my sort of my closing slide. So now I sort of want to engage with you and yeah. I showed some interesting stuff, and this is what people are going to walk away with. So anyway, my fault. So now I sort of want to use the time left and engage with you. I promised I'm curious to poke and learn from you now. So let's break the ice. Who wants to break the ice and share one of these sort of unexpected stories where some kind of pattern or idea sort of was not what you expected and caused some surprise? Go ahead. Oh, we have a mic. Excellent.
Thanks for the talk. I think we need to It's on. I can't hear myself.
No, I think it's off.
Probably on, but needs to be turned off. This is unexpected. Unit test 1, unit test 2, unit
now
test
it works.
3.
Yeah.
Now it works. Perfect. Yeah. So thanks a lot for the talk. We once had a custom time type, like a class that had like how many seconds, how many minutes, and how many hours, and so on and so forth. And then they slapped an equality operator on that. And in the equality operator, they decided, actually 3,600 seconds is 1 hour. So if we have 1 hour and we have 3,600 seconds, it's the same. So of course it has to return true. And I said, are you crazy? This is going to cause some weird shit.
So what kind of stuff did you see? Or was it, didn't make it past the review thing?
It made it past the review, and fortunately it was used in such a narrow context that we could contain the craziness. And it's basically now it's an encapsulated, like, don't go here, piece of code. And I can live with that.
Oh. This coping mechanism of we wrapped it here in this corner and we're not touching it is something I see frequently, and sort of depresses me. One of the things, as you mentioned, time primitives. One of the things I'm seeing a lot with time primitives is people misusing affine transformations on time. The kinds of operations, going back to operators and how you add and subtract these kinds of things when you're dealing with time points and when you're trying to calculate time spans and these kinds of things, where it was way worse before we had Chrono. So Chrono brought back some sanity. I don't know how many projects are actually using Chrono, but I've seen some real egregious things which relates to defining operators and functions on time points and calculating spans and the kinds of operations they allowed. I've seen some freaky stuff. I think we have some.
Hi. When you showed your slide with a my string and you said you're protecting the intent, that you know the names, and I was wondering if you were talking about some people that I know, because I've seen exactly such a string class, just much worse, which had everything was implicit, various constructors from various other kinds of types and integers and doubles and everything, and also everything there were operators. And this was working on the MSVC compiler. On Clang it didn't even compile at first when we tried it.
Classic story.
Yeah, and we had to refactor it and clean it up, but there were so many weird problems and you couldn't use various things in various orders, and it was really crazy. So we're unlikely to talk about the same code base, but yeah, I've seen this. Yeah.
I think we've all seen this.
Yes.
It might not have been a string type, but we've all seen this stuff.
So my main takeaway always was, even before I saw this, as doing too much stuff implicit, operators, constructors, is really, really bad, especially when it comes to such fundamental types like strings.
Yeah, and cramming too many operations in a thing, just we might need it in the future. It's another nice thing I've seen.
Well, the bad thing is it was used, all of it, all over the place, and that made it so hard to get rid of it. So
yeah. Thanks for sharing. I made a joke, but it's actually is from. It's not an invented example. It's a simplified example. I'm not joking. It's actually real code I've seen.
Yeah, I'm still a bit upset about the file system, where I figured 20 minutes about how to concatenate a path until I found it's the division operator, but I don't want to divide a path in two halves. I just want to concatenate it.
Somebody was clever with that one, yeah. Also with how we're using plus for strings, you know. We're adding strings, but we got used to that. It's worse in PHP. You need to put a dot between them. Who came up with that? There's another one here.
So completely different story. A story where I wished it would have worked out. I had some filtering to do, so I decided, okay, I would write a pattern for a filter function, and you can replace it. And then, of course, you can do like filter A or filter B. Filter A and filter B, you can combine those. Mm-hmm. And it would have looked so pretty if I just would have overloaded the operators, and then people on the Discord said, you should probably not do that because you will get some weird side effects. So in the end, I hid it inside my source file where I had full control that nobody bleeds when I overload operator, pipe or operator. Well, they said don't overload the operator with the two pipes or the two en passants. If you have to do it, at least take the one with one. I never fully understood why.
Yeah. Well, again, it's about breaking expectations about how you're using the stuff. I've seen people do weird stuff with logical operators, and yeah, I'll stop there.
I've got another story about versioning. I'm working with a protocol, and the author of the protocol learned about semantic versioning right in the middle. So there are two kinds of versions, and the first one just is equal if major and minor is correct, and the other one is equal if it's major, minor, and patch. And so you're working with the protocol, you see a lot of occurrences of versions, and you really don't know if you're comparing just major and minor or the whole thing.
Yeah, I'm guilty of implementing a version class in the past, way back, maybe 18 years or so, no, 17 years, I don't know. I've done a version class myself that supported operations and comparisons and all sorts of quirky rules about how we handle. Not all parts of a versions are born equal, so there's build numbers and alphanumeric sections of versions that need to be compared differently and or excluded from some kinds of operations, and I know some of that pain. More recent story, I'm a huge Rust fan. Sorry, wrong room, but I love Cargo. Cargo is such a huge enabler and helps enormously the community and people working with Rust and managing dependencies and handling semantic versioning for dependencies. You would think, so the tool works brilliantly until you read more about how semantic versioning works for versions less than 1, so 0 point something. There's like a page, I'm not even kidding, it's a page that you need to scroll in the browser explaining special rules that happen when version is more than, it's 0 point something, and there's ranges and exceptions, and I don't know it. I still, to this day, I don't know it by heart. Every time I'm looking at it, it's like I need to read the documentation. It's like this long. I'm surprised they don't have like a markdown book about it. And there's tools that help. So tools make an enormous difference. But then again, it's about trying to encode in a simple concept so many corner cases and things that I'm not saying they're not necessary. They were necessary. They have a reason to be there. But they encoded in a simple concept such a complicated contract. And you can't use it unless you're the sort of, you know it, you're the expert on it, or you're just, let me check this corner case. It's like a lawyer. I need to check this clause in the same verb rules to see how this thing should be defined in my TOML file. It's scary. Yeah. Versioning, semantic versioning. But I loved how you started, like they discovered it in the middle of the process. It's like, that premise already made me happy.
I have a story here from online.
Yeah.
Mike Crow writes, Hubert Matthews gave an interesting talk at ACCU 2018 entitled Read and Write Considered Harmful, explaining that whilst people consider read and write opposites and therefore symmetrical, they aren't really.
Interesting. I never thought about this aspect, read and write. But I did think about serialization and deserialization. Anyone has cool stories about serialization? No? Too afraid to share? No worry, we're among friends. I'll catch you later in the hallway. You can tell me off record. I know some stories, but I can't share.
What kind of story are you interested in specifically? Because I have a lot of stories about serialization.
Things that didn't work as you expect them to.
Yeah, I have a story about serialization.
Go for it.
The thing is, so when we serialize something, you could also get a message of size 0. However, our transport mechanism was not support to transport messages of size 0. So then we had to increase them to size 1. However, send 1 byte, and then the trouble got when we got this byte to deserialize that back to get the original content.
That's a wonderful hack. Thanks for sharing. Any other questions or stories you want to share? Otherwise, I'm sort of ready for lunch.
It's not about serialization, but
yeah,
every
anything.
time I see metrics
and multiply matrix. I'm always confused. Is it element-wise multiplication or is it actual matrix multiplication? Always have to go and check that.
Okay, interesting. I never had to deal with these kind of things. Matrices didn't enter my life in programming, only in physics. There's one over here.
Allow me to flip this upside down. You have a lot of experience in C++. You love Rust now. What things work in Rust that you did not expect coming from C++?
What things work or don't
Or
work?
what things in Rust did not work as you expected them to work coming from a C++ context?
That's a tough one. Well, I would say, but does it have to be a bad surprise or a good surprise?
Literally what you asked us, I'm asking you. Things that you not expect, good or bad.
Yeah.
And they don't have to be with Rust. The point I'm trying to ask is more how much of our implicit biases from a language do we carry to another language, and how do they surprise us?
Oh, that's a different formulation. I think we all do this. When we start a new thing, we sort of carry some baggage with us, and I don't necessarily see it as bad. I see it as sort of baby steps in that journey. I certainly did. So when I went into Rust, I operated in two modes, because I went to Rust and I was already sort of a Haskell, so I liked functional programming and C++, sort of weirdly different things. So when I started programming Rust, I would either go full functional and sort of write everything in iterators and iter tools and chaining computations and sort of building monadic transformations everywhere and sort of building huge chains of stuff. Or I would go full C++ mode and be like imperative and everything should be mute, right? Gradually I sort of try to go towards idiomatic things. And the only thing that helps is actually reading good quality code. And sort of going, okay, now I see. It's like this is the better way of doing the thing that I've been doing, right? So the more code you read, the better you're gonna be at writing better code. Even reading bad code, you'll gradually you'll start to identify that this is kind of crappy code. But you learn from it, like seeing these kinds of things. So yeah, there were some surprising things. I would say maybe most disconcerting things were syntax. I found it rather ugly, noisy. But yeah, most pleasant thing, by far my favorite feature is enums and pattern matching in Rust. And could say it's surprising because it's not what you expect. And the way you tend to use it initially is sort of use it in a very awkward way, very simple things, because you're afraid you don't understand how to unleash the full power. But again, going back, the more you see others do interesting things, and you understand, oh, this is how I'm supposed to be doing it, right? Yeah, and dealing with some types, and in general, it's something that you need to gain appetite for and learn. You can do amazing things. You trapped me into the Rust rant. If you don't have any other questions, let's go for lunch, and we can talk about with some food in our mouth.